Good morning, Year 5. Welcome to your Monday maths lesson. Today we're going to be continuing on with our fractions work, but today we're going to be looking at fractions greater than 1. So I'm going to warn you that as it's Monday morning, we're going in very hard, good start to the week. So there's going to be quite a few in-lesson tasks. So throughout this video, I'm going to have you stop and answer some questions. So here is my warning. You are going to need a piece of paper and a pencil, and then we're going to begin. So before we go into today's learning about fractions greater than 1, let's start with a little warm-up about what you learnt last week and equivalent fractions. So your little mini task, first of all, is to match the equivalent fractions. Now I know Mrs. Moore told you the rule that what you do to the top, you must do to the bottom of the fraction, and to find an equivalent fraction, you can multiply or divide the fraction by the same number. Both ways will give you an equivalent fraction. So pause the video here and have a go at matching these equivalent fractions. So Year 5, here you go. Here are the answers for the matching of the equivalent fractions. If you've made any mistakes, just have a look which ones you've muddled up, have another go and see where you went wrong. I'm sure if you have a look at the answers, it'll be able to help you with where you went wrong. If you got them right, brilliant, well done. Okay, Year 5, so what we're going to look at today is fractions greater than 1. So those are fractions where the numerator is greater than the denominator. So we have a fraction here displayed. We have 7 equal pieces and 7 are shaded. So we have 7 sevenths. So when the numerator and the denominator are the same, that's the same as 1 or 1 whole. So let's add some more sevenths. Here we have 2 more sevenths. 2 sevenths. So how many sevenths are there shown on the screen in total? Well, we know that 7 add 2 is 9. So on the screen, there are 9 sevenths altogether, which can be showed as 9 sevenths. So as you can see, the numerator is greater than the denominator. So here we can see this again. We can see that 7 sevenths equals 1 whole, and we have 2 sevenths. So altogether there are 9 sevenths. So 9 sevenths equals 1 whole and 2 sevenths. Okay, let's have another look at another fraction. So here we have 6 equal pieces and we have 2 shaded in. So this is displaying 2 sixths. Now let's add some more sixths in. Again, we have 6 equal pieces and this time we have 5 shaded in. So we have 5 sixths. So altogether there are 7 sixths, because we know that 5 add 2 equals 7. So we have 7 sixths, which can be displayed like this. So here is this. We've moved around the coloured in sixths so that you can see that we have 1 whole and 1 sixth. So 7 sixths equals 1 whole and 1 sixth. Okay, Year 5, here's your first mini task. So you just have to read questions 1 and 2. So with question 1, it says there are blank thirds all together. So you simply count all the coloured in thirds, and then you work out however many thirds there are equals how many wholes and how many thirds. And then you do the same for question 2, but this time your shapes have been split into quarters. So you count how many are coloured in, and then how many wholes, and then how many quarters there are. So pause the video here and have a go at that, and then when you play the video again, we'll go through the answers. Okay, so here are your answers. So we're looking at question 1 first. So as you can see, there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 thirds altogether. And we know that 8 thirds equals 2 wholes and 2 remaining thirds. So let's look at question 2. So if you count all the coloured in quarters, you'll see that you have 10 quarters altogether, and 10 quarters is the same as or equivalent to 2 wholes and 2 quarters. Now, if you didn't get this quite right, just go back to the previous, slide back slightly and have another go and just have a look and see where you might have gone wrong. Okay, here you go, you have another go, but this time we are using fifths. So there are how many fifths coloured in altogether, and then you need to tell me that number of fifths equals how many wholes and how many fifths. So pause the video here and have a go at that. Well done for having a go. So as you can see, there are 11 fifths altogether, and now we know that 11 fifths is equivalent to or equal to 2 wholes and 1 fifth. Right, here we have a fraction, and we can see that the numerator is greater than the denominator, as we can see that this is showing 12 sixths. So when the numerator is greater than the denominator, this fraction is known as an improper fraction. So how would we go about drawing 12 sixths? So first we would draw 6 sixths. So we have 6 equal pieces, all coloured in, so we have 6 sixths. Then we would add another 6 sixths, because we know that 6 and 6 is 12. So we can clearly see that 12 sixths is equal to 2 wholes. Okay, so here we have another improper fraction. This fraction is 18 sixths. So how would we go about drawing this fraction? So we would first draw 6 sixths. We would then draw another 6 sixths, which we know 6 and 6 would give us 12 sixths. And then we would draw another 6 sixths, and we know that 6 add 6 add 6, or 6 times 3 equals 18 sixths. So we now know that 18 sixths is equal to 3 wholes. Okay, here we have another improper fraction. This time our fraction is 20 fifths. So how would we go about drawing this fraction in order to work out how many wholes 20 fifths is? So first we would draw 5 fifths. Then we would draw another 5 fifths to give us 10 fifths. And then 15 fifths. And then you can see where this is going, 20 fifths. So we can clearly see that 20 fifths is equal to 4 wholes. Okay, so we now know that 20 fifths is equivalent to 4 wholes. But why is that the case? Well, we can see that 5 multiplied by 4 gives us 20, and 20 divided by 4 gives us 5. So we now know that 20 fifths is equivalent to 4 wholes. Okay, year 5, here's another mini task for you. So here you have 3 different improper fractions. You have 15 thirds, 8 halves, and 21 sevenths. So you need to tell me, with question 1, 15 thirds is how many wholes? Now think about the previous slide where we were looking at 20 fifths, and just have a think. 3 multiplied by what gives you 15, and 15 divided by what gives you 3. You can also draw your part whole models for this. So you could do 3/3, and then add another 3/3 and colour them in another 3/3 and see how many holes it takes for you to get to 15/3. Okay, pause the video here, have a go at these, and then we'll give you the answers on the next slide. Okay, here are your answers. So 15/3 is equivalent to 5 holes because we know that 15 is 5 times greater than 3. 8/2 is equivalent to 4 holes. 21/7 is equivalent to 3 holes. So I'm hoping that you got these right and that you were able to use your part whole models to help you out, and also your multiplication and division fact knowledge. I'm hoping that helped you. If you didn't quite get it right, have another go. Think about my answers, draw out these models and see where you may have gone wrong. Okay, so what we've seen so far with our improper fractions is that when we turn them into how many holes there are, we're left with only holes. So if we're looking at 10/6, it's going to be slightly different. So if we were going to draw this in our part whole models, we would firstly do 6/6, that would be 1 hole, and then, but we have 10, so we need to draw another 4/6. So here we go, we have 4/6. So we can see that 10/6 is equivalent to 1 hole and 4/6. So now we have some sort of like remainders. We have 1 hole and then 4/6 remaining. Because as we know, 10 is not a multiple of 6. Okay, here's another mini task for you. So now you have some more improper fractions, and I would like you to calculate how many holes and parts, or holes and fractions, both of these improper fractions go into. So if you need to draw pictures, that's absolutely fine. In fact, I recommend you draw pictures to help you, and then we'll have a look at the answers on the next slide. Right, here are your answers. So number 1, 11/3 is equivalent to 3 holes and 2/3. And number 2, 9/2 is the same as 4 holes and 1/2. Now, if you do your drawings, it is much easier and you can very clearly see how this works. If you've managed to do it without drawing, then brilliant, well done. Right, well done Year 5. It's now over to you to complete your worksheet. You have a couple of questions that we've covered today, and then you have a challenge question, which is using all the similar ideas we've talked about today, but it's in a word problem. So I appreciate we've done lots of in-lesson starting tasks for you. So if you don't want to do the challenge, that's absolutely fine, but if you're feeling very brave and you want to, then have a go. Well done for today. I know there's quite a lot to get through, and I will speak to you tomorrow. Good luck with your worksheet.